Okay, friends, take out your notes and turn to the slope part of it. I'm going to try and do my best to over-explain slope, because slope isn't going away. Every math course at St. John's uses some version of slope and does more and more complicated stuff with it. So we've got to get slope narrowed right down. Here's what the notes say. The slope of a line M, why in the world would anyone have chose M to represent slope? Monte, yeah. It goes back to René Descartes from yesterday. René Descartes was the first one to write a really good, popular textbook on Cartesian planes and graphing points. And of course, he was French. So he called slope Monte, rise. So he called it M. And then everybody who wrote a textbook after that used M. And here we are, hundreds of years later, still using M for slope. Everybody does it, M for slope. Is the measure of how steep a line is the greater the magnitude of M, the steeper the line? Ooh, fancy word, magnitude of M. Just the bigger the number. Whatever the number is, if the number is bigger, we're talking about a steeper slope. A line with positive slope rises to the right. Ooh, that's slightly troublesome. These notes act like, oh, no problem. I don't like that color. But maybe it is a bit of a problem. Let me just pose a little situation here. I'm going to have one line on one graph going this way. And then I have one line that way going that way. One of these is called positive, and one of them is called negative. But you need to work on your brain just a little bit just to make sure it's clear why one would be positive and one would be negative. First of all, which of these ones is positive slope? This one here is the positive slope. And this one here is the negative slope. Maybe you know that. You've memorized it. But there's a reason that is when we take this information we're learning about slope over to science class, this bottom axis will be the independent variable, oftentimes, and we'll start looking left to right. So most graphs we look at, we go left to right. So this would be going up left to right, whereas this would be going down left to right. So left to right is an important little deal there. Let's make sure the notes say that. A line with positive slope slopes to the right, rises to the right. There, yes, let me underline that. Rises to the right, whereas a line with negative slope rises to the left. Or, let's just add to that, or falls to the right. Another way to say that. Both are good. A horizontal line has slope 0. So if a line doesn't go up at all, we call it zero slope. Hello. While a vertical line has slope that's undefined. What? How can slope be undefined? Well, let's go to a ski slope. I know it's not in a good year for skiing, but let's talk about slopes and that what you might like to ski on. Let's say you're a beginner and you're just learning to do skiing. You might like a zero slope. Maybe you wouldn't even call it downhill skiing. Maybe you're like, hey, if I do downhill skiing and the slope actually is 0, I don't know if that's actually called downhill skiing, but it might be where you want to start when you first learn to ski, yes? Then, after that, you might want to go to something that's slopier. Slopier? That's not the word we use. Steeper, yeah? Because that's more fun. However, if you got somewhere and there was a ski run that looked like this, I hope we can agree that this is a problem. That's not skiing. That's parachuting.
How do you ski uphill?
It's very hard work. It's very hard work, yes. The point of the example, though, is zero slope, and this really isn't talking about slope. There's something different about this line. And it's okay at this point if we're just like, okay, vertical lines are different. Yeah, they just don't fit the regular rules. It's sort of a special line that there's no way really to talk about what the slope is. So maybe at the ski hill you'd be like, oh, beginner slope, hey. And then it's like, ooh, black diamond, crazy. And then this would have a big red stop sign going, do not try and ski this. This is not ski slope. And the analogy falls apart a little bit for you skiers, like, ooh, well, you could do it. Yeah, you do, I don't know. Vertical lines have a slope that's undefined. We don't have any way to talk about what that slope is. And when we go to do rise over run, we'll see why in just a second. Parallel lines have equal slopes. That's easy enough. If the lines are parallel. Ooh, I wanted to label these before I forgot. Hang on, let me go back to my pen and label these. This was zero slope, and this one's undefined slope. We have no way of giving that a definition. Parallel lines have the same slopes, while perpendicular lines have slopes that are negative reciprocals. What? All right, hang on. A couple of parallel lines. I need a picture here. Little parallel. Such an interesting word. The word parallel has a bunch of L's in it that are parallel. I don't know if that's by accident or not. I don't know. It's a happy coincidence, though. This is how we call that serendipitous. She'd say, that's lucky. She loves that word, serendipitous. Now, this is a little harder to draw. I got to be a little careful here, so don't draw something that you look at and go, I don't think you did a great job there, Mr. But there. These lines are called perpendicular. Oh, this is coming soon. I think last year in grade 9, perpendicular, we just said, oh, it's perpendicular. Yeah, slopes. Negative reciprocal, boom. We'll do a lot more with that. What do you mean by negative reciprocal? It means if the first slope was 3/4, the second slope was negative 4/3. The rise becomes the run becomes the rise, and you change signs. No? Does that ring a bell? If not, I'm explaining it here. And when it comes up in the second chapter of this course, I'll keep re-explaining it. So it's not going to be like I'm just going to, like a hand grenade, drop it in your lap. I'm like, oh, perpendicular. Like, mentioning it here. You saw it in grade 9, hopefully. Do you remember this negative reciprocal thing? Fancy words, spicy words, yeah? Determine the slope given. I'm going to do this 2 different ways. Over here, getting ready for the third example, okay? What I said over here was slope. Right here. Ooh, I almost skipped over it. Look at. To calculate slope, you've got lots of choices. You can use rise over run. Great way to do slope. In fact, if you look at the back of my room, it's one of the only posters I hang up. Slope is easy and fun. Just remember rise over run. Don't underestimate how powerful that little sentence is. Rise over run. To do rise over run, we can do y2 minus y1 over x2 minus x1. It is totally fine if at this particular moment you're like, I don't know if I remember how y2 minus y1 works. What does the 1 mean? What does the 2 mean? I'm going to do that right in the next slide, okay? It's just there for you right now. And sometimes we call this delta y and delta x. Those symbols we'll use as a reference right now, but those are going to become important symbols as we move up through the grades. But here, this is what you really need to know. I'm going to develop those formulas right there. I'm going to make them. Instead of using rise over run, by the end I'm going to show you the slope formulas. So, slope is rise over run. Why is slope rise over run? Here's a little example to help you out. Let's imagine for a second I was looking for one of you to hire one of you as a babysitter for my kids this weekend. Yes? And I said to you, do you think you could come babysit my kids for $50? Now, if you're a clever math individual, you would ask a follow-up question. Because there's something missing, isn't there? What's the piece of information that's missing when I just say, I'll offer you $50 to babysit this weekend? How long am I babysitting for? Because if I say, here's $50, can you come over Friday at 3 and I'll get back at Monday at 8 a.m., you're going to be like, $50? Well, it's still $50, but wow. That's a lot of run, as I snuck in the math word. I've got to take how much rise, the $50, but I got to divide it by how long this is going to take. If I say, oh, come babysit my kids for an hour while I go out to dinner, $50 for an hour, that's pretty good slope. That's pretty good rate. You'll be happy with that rate. but it really depends on how many hours. Let's go back to the ski hill. If I say a hill drops 50 meters, are you scared? Maybe you are. But maybe you should ask another question. What's the other question you should ask? Is 50 meters a... Let me go to a new thing here so you can really see it. If I tell you that the hill you're going to go down, and I'll do it the other way around, over here, drops 50 meters. Are you scared? I've given you the rise. What other information do you really want to know? The run. Without the run, I don't know how steep this hill is. If I could say, okay, well, we're going to run 1 meter. Are you scared? I hope you are. If it goes 50 over 1, that's going to be steep. But if it's 50 meters down, in 4,000 meters, I'm not too worried. You see? That's why rise and run. To get the slope, to find out how much this is changing, I need two things. I need how much is it changing and how long does it take to do that? That's rate of change. Sneaking in a word from a later grade. So when I want to do this rise or run, I need two things. I hope they beat you up with this in grade 9, but if not, here, we're going to do it right here. To get the rise, you just draw this thing called a rate triangle. Did you do it in science? Did you guys do rate triangles yet? Get ready. Get ready. In future grades, especially you take like grade 11 physics, you'll do rate triangles. That's what this thing is. It helps find rates. You go, okay, and now I can easily see the rise. 1, 2, 3, 4. That's how much it rose. I can count the squares. 1, 2, 3, 4. And then the run is 1, 2. I'm going to label that on my picture. And maybe rise over run, maybe this is the first time where you go, oh, I really get that now. The rise and the run. I need both. So this slope is 2. Let's jump ahead a little bit in our thinking, all right? I'll physically do it at the front of the classroom so you can see. I'm actually going to go, okay, this is where we're at right now. I'm going to try and go, let's just jump ahead in our thinking a little bit. What's the weakness of graphing in finding slopes in general situations? What's going to be the problem here?
Making a graph.
Making a graph. Well, that can be annoying to begin with, just making a graph. But what kind of numbers are going to make making graphing a big problem? Negatives are a challenge. I handled negatives here, so maybe negatives are a problem. Decimals. That's where we're going with all this. If we're actually going to use this in the real world, the numbers aren't going to be 4 and 2 necessarily. They might be 7.26, negative 3.84, and then graphs become not very useful. So graphs are nice. They're beautiful to see what's going on, but we better have something more available to us to find out these rises and runs as the numbers get into decimals. But there's another type of number. What type of numbers are going to make graphing this thing really, really challenging? This one went up to 5, my graph. What if the numbers are like 8,000? Graph's going to be a problem. Yeah? Imagine plotting a course to Mars and the numbers are millions of kilometers and I want to find the rate. And I don't want to do it on a graph. So graphs are good for ideas and graphs are good for visualizing, but for actual calculations, we better have something more. So what's the something more? Take a look at the numbers here between 1 and negative 3. What could I have done with a y value of 1 and a y value of negative 3 to end up with 4? What operation do you have to do with 1 and negative 3 to get the answer 4? It's subtract. Yeah, you got to subtract them. You got to go 1 minus negative 3. Is that better in this example? I don't know. These are pretty nice numbers. When it's pretty nice numbers, rise over run's raising its hand going, can you just let me do the question? Rise over run, pretty nice. And the answer is, yeah, I think so. Rise over run, I think, might be a little bit better in this particular question. And then the run, it went from 1 to -1. I've got to subtract those numbers. So we have a way to get rise and run. If the numbers get crazy, just subtract the two numbers. And that's all that formula was saying. This formula is like right here. It's like, well, you can graph it if you want and get the rise or run, but if you want to be math cool, maybe this is the way to go. Because then you're ready for big numbers, decimals, whatever. You don't care. As long as I got my calculator, I can do rise or run of any two things. And you can't see it on the video, but I got to tell you, in calculus class, look what we were doing right here today in calculus class. It doesn't matter what the symbols are. It doesn't matter about all that, some crazy thing we were working on in calculus. But in the end, we were just finding out how much something was changing. And we did this value, subtract that value. We just did y2 minus y1. So that idea is not going to go away. It bailed us out in what we were working on today. You don't have to understand what's on the board. It doesn't matter. What matters is that we're going to use this idea that we subtract to find out how much something's changed. You can do it on your bank account too. I got paid this morning. I really did. I got paid this morning. And if I look at what my account is after I got paid and what the number is before I got paid, if I subtract those two numbers, I know how much I got paid. Okay? I'll do one more with the graph, and then I'll switch over to this one, and we'll do no graph. And not because these numbers are difficult, because they're not. In this third example, we could graph them easy enough, but because we want to get better. Okay? So this one here, I encourage you to draw the rate triangle, not just to get ready for science class, but it prevents errors when you're using rise over run. You go m equals rise over run. And if the numbers are nice and you've got a beautiful graph, well, you can just count the squares. 1, 2, 3, 4, 5, 6. And the run 2, and the answer is 3. It's not 3. It's not 3. What is it? -3. I don't know how you're going to handle this. Everybody's different. Some people go, it's a perfectly good way to do it. I'm just going to do a rise or run. And then I'm going to use my brain and look at the line and go, was it going up or is it going down? Oh, this one's going down. So the rise was negative, and they fix it afterwards. You can have your own system, but in the end, if they're going down, you better write negative. And then somebody goes on a test. My calculus people all the time, well, I just missed the negative. It's no big deal. I'm like, it's a really big deal. It's only the biggest mistake you can make. Can you imagine today, instead of getting paid, I forget how much I got today, $2,600 or something? I'm not bragging, just encouraging you who want to be teachers. Works out pretty well after you've been here for a while. Imagine they, instead of putting $2,600 in my account, they took out $2,600. Do we agree that's the biggest mistake you can possibly make? What would that do to my day? I wouldn't have come into work today. Not because I'm not coming in if you don't pay me, but because I'd be freaking out. I'd be like, that's a big problem. So let's not underestimate how big a deal negatives are. Imagine for a second you're flying your spaceship to Mars. And instead of going straight towards Mars, you go straight away from Mars. That's about the worst mistake you can possibly make. All right? So don't underestimate negatives and how important they are. All right. We're going to do this one with the fancy formula so that we're ready for any numbers that come along. M equals y2 minus y1 over x2 minus x1. That's your new best friend. That's one of the best formulas in grade 9 or 10, so I'll put it in this nice heart bubble. Don't need to send a carnation to somebody for Valentine's Day. Don't need to text back and forth to people. You got this. What else could you want? Perfect Valentine. Does anyone remember how to do this thing, though? What do these 1s and 2s and everything mean? What kind of thing should I do to get ready for this thing? y2 is -2. The 2s and 1s, all they indicate is which point are we talking about. So over here, this is going to be the second point in the question. So I'm going to do this one over here is y2. I encourage you to label these points. when you first start and go, okay, that's the second point, and I get that's x2 and that's y2. That means in the first point, this is x1 and y1. And if you're good with subbing and algebra, the party's over at that point. Yeah, the rest of it's just subbing in those particular values. The second y value is -2. The first y value is 6. The second x value is -3. And the first x value is -1. You got to be a little careful with the negatives here, though. Negatives are big trouble here. And I get -8, -3 subtract -1. -3 subtract -1 is like -3 add 1. So it's -2. Ooh, science people. 3 electrons. Take away 1 electron is 2 electrons. Maybe this whole subtract and negative thing, maybe there's more than meets the eye of this. Maybe there is a way to understand what's going on with negatives all the time. It just takes a little time. And I get -8 over -2, I get m equals 4. Well, there should be 2 questions after all that. The first question should be, are you sure? It's a little scary when you do formulas like this. Like, formulas are very powerful, but it leaves you going, I don't know, I'm not sure if it's right. So I encourage you to take out a piece of graph paper when these things happen and go, okay, maybe I'll just graph it and make sure. So I got some graph paper I'll use here. You don't have to, but I just want to show you so that I encourage you to go, oh, if I'm a little bit stuck, I can just graph these things. Here's my graph paper. Where was I? What were the points again? -1, 6. There. -1, 6. First point. Second point was -3, -2. Oh, I got too many flip charts open here. -3, -2. Are we feeling a little bit better about this slope being positive now? You're like, oh yeah, it's okay. Yeah, that didn't take too long. If you got a little graph paper beside you when you're writing a quiz or test to go, let's just take a look here, make sure it looks right. And then we'll just look to see, is it going up by 4s? 1, 2, 3. Yeah, it's going up by 4s. Oh, good. It's right. Yeah? So then you have a little more faith in the formula. And I encourage you to do those kind of things just to feel better about the whole situation. That's the first question that should be out there. Here's the second question. Get ready for this. Wouldn't I get a different answer if I use this as the second point and this is the first point? See, I got -8 over -2. Wouldn't I get a different answer? Well, I'm going to go down here and do exactly that. I'm going to do it all in reverse and see what happens. So instead of using this as the second point, I'm going to use this as the second point. And I get 6 subtract -2. And then -1 minus -3. So given 2 points, you could do it the other way around and get a different answer. Oh no, math is broken. What's 6 minus -2? That's 8. And you're like, see, let's look at it. You got -8. I got +8. It's going to be a different answer. I smile, go, keep going. Go, okay, I'll try it. -1 minus -3 is +2. 8 divided by 2 is 4. Of course, math's not broken. Someone thought of that before and checked it out and said, no, if you do it the other way around, as long as you reverse both the x's and the y's, you'll just get the opposite sign, both top and bottom. Those opposite signs will cancel, and you'll get the same answer. So no worries. You can select the points whichever way around you want, and if you do it correctly, you'll get the same answer. They were supposed to really beat you up with this in grade 9. Did you do a lot of slopes? Yeah? And is that enough to scrape the rust off, or you go, okay, I can try this now that I've seen it? Is it okay? If not, yesterday in grade 11, a student came to me having trouble in their grade 11 class. First couple days of review, they're already like, I'm not sure I'm getting good at this. I got textbooks and sheets and books here everywhere. I gave them a book and said, here, Use this. Go home and review with this a little bit. These pages, these questions, they're zipping through it and they're catching up. AP, that's what AP students are about. AP students are like, I don't care if I'm ahead or behind. If I'm behind, I'll catch up. If I'm ahead, great. So if you're stressing about any of this stuff, no worries. Come and see me. I'll give you a couple things to work on. You'll work your way through them. Everything's going to be fine. Okay? Where was I? Slope. Done. Slope. Done. Do you need more time there? The voice is going. Is this the next thing in your note? It's a huge leap. It's a huge leap. So I ask you, because I want to know how hard this is. Because this question is either impossibly hard or unbelievably easy, depending on what you know. What's the slope of a line parallel to y equals negative 4x plus 9? Destiny? She's all over it. Let me just add a little bit to what she said. I first ask, what's the slope of this line? If we want a line parallel, we need to know what the slope of that line is. And this is where y equals mx plus b comes in. And if y equals mx plus b still seems like a bit of a mystery to you, I encourage you, whenever you get the equation of a line from now on, just write y equals mx plus b over top of it. That is a powerful move. And maybe you can do that mentally. Maybe you're so good at it that mentally you can see y equals mx plus b over top of it. But if not, that's a great way to handle it, because when you look at this, it says, here, when you get an equation, it'll be y equals, and whatever number there will be the m. That's the slope right there. So the slope of this one is negative 4. It's tempting to say negative 4x. If you write negative 4x on your quiz, will I mark it wrong? You know, I think I'll do the angry dance if I do that. You know little children, how they do the angry dance? If you tell a small child to do something they don't want to, their whole body objects. Happened last night. I told one of my children, it's time for your shower. They did not want to shower. They wanted to continue playing on their iPad. I said, it's time for your shower. And this child did this one. Do you know what I'm talking about? Have you ever seen this before? They go, they just get all upset like that. Yeah? I think what I'd do on your opening quiz, if you wrote down slope equals negative 4x, I'd stare at it a long time and I'd be like, oh, geez. And I'd probably mark it wrong and give you all the marks. Yeah? I think that's how I'd handle it as a teacher. Like, oh, we're in good shape. I can't take the marks off yet. Yeah, I don't want to do that. Because you're identifying correctly what's going on here. But it's not negative 4x. That's not correct. The slope is negative 4. Slope is a number, not the variable as well. It's a spot right there. That number right there before the x gives you the number of the slope. Mr. Todd, technically you wrote m up here and you wrote another m down there. And this was the slope of this line. This is the slope of your new line. I'm like, okay, well, technically maybe I should write two little lines there. That's how we write parallel. But I'm not really teaching that today. I'm just mentioning that. And we want to do parallel lines. We could use a little symbol there going M parallel. Yeah? Smooth math stuff, but not necessarily here. Maybe a statement is better here. Yeah? They're teaching you to do statements, right? Therefore, the slope of a parallel line would be negative 4. I mean, that's the technical, nice way to write these things. Any questions about that? Where's my controller? Oh, there it is. Everything's fine. Don't panic. I got it right here. You don't care. All right. Questions there? Next one, determine the slope of a line that's perpendicular to this. Okay, here's the steps to this. If you're having trouble with these, they give you the equation of a line. You write over top of it y equals mx plus b, which again, maybe you're doing that mentally now. where you don't have to write it over top there, but I like that move if you're having any trouble and go, okay, that means this line has m equal to -3/4. That's the slope of that line. That's like level 1, grade 9 stuff. Can you just look at an equation and grab the slope? Level 2 is, what's the perpendicular slope? So I write this fancy symbol. That's the little fancy symbol for perpendicular, and I could do it with words as well. I'm just giving you some new symbols that you could use if you wanted to. Perpendicular slope. Who wants a shot at this thing? It's fun to make perpendicular slopes. If this is -3/4, what's the perpendicular slope? Positive 4/3. I like that he said positive, so I'm going to put the positive there, even though you don't need to write the positive there. The rise becomes the run, and the run becomes the rise. When I say it like that, that makes perfect sense to me for perpendicular. If I'm going to be perpendicular, the rise and run have to reverse roles. And of course, if it was going up before, it's going to be going down now. If it was going down before, it's going to be going up now. So this changing the sign thing is not all that mysterious. If you do perpendicular with any line, not with any line, not with any line. But if you do perpendicular of most lines, positive ones become negative, negative ones become positive. What's the line I'm referring to? It's a little bit trouble in all this. What line doesn't really follow these rules? The vertical and the horizontal. You just have to know when you're under those. If you go perpendicular to slope 0, you get undefined slope. If you get perpendicular to undefined slope, you get 0 slope. So there's one special case in all there. I'm not trying to teach that separately. I just want to mention that just in case that was rattling around like a little marble in your brain going, oh, what do I do if it was 0 slope? Like, we're okay, we got that. It's just a special situation. That's all of that for now. So this was supposed to be the most fun you could possibly have in grade 9 right here, graphing lines. It's got a little sneer there. Method 1 of graphing lines, using the slope and y-intercept. Here's all the steps. You know what? I'm actually just going to do it instead of reading it. And then I'll read these steps afterwards in case you're like, oh yeah, I don't remember some of that. The steps are there for you. Here's what you were supposed to do. You were supposed to look at an equation of a line, y equals mx plus b, and you were supposed to look at that number, the number that wasn't with the x, and identify that as the y-intercept. That tells you where this graph meets the y-axis, and in this case, it meets it at the number 2. Now, graphing lines is pretty straightforward. You only need 2 points, and I'm already halfway there. That's why the y-intercept is so important. It gives me a point to work off of. I already sort of know what this line is going to look like. I don't know what angle it's going to go off at, but I know it starts at 2 on the y-axis. Then I look at this and I go, okay, so that's the slope, m equals -3. And for the first time in your life, you wish it was a fraction, because slope is rise over run. But this one doesn't have a denominator. So what am I going to do with this particular slope to get ready for rise or run? Right, so I always have that option to put something over 1 if I need to. That doesn't change its value. Dividing by 1 doesn't change it. And now I can identify this as the rise and this as the run. And I can build my little rate triangles to bring that idea back in from the y-intercept to get new points. I got to run 1 and rise -3. How do you rise -3? Down, that's all. That's all rising negative means. So I run 1, rise -3. Run 1, rise -3. Do you need this many points that I'm doing here? No, but it helps to do a few extra points so that when you put your ruler on the page, you get it exactly in the right spot. The rule I used to make in grade 9 is, let's get at least 3 points before you slam your ruler down. What's the ruler situation in my room? Some of the other teachers come and steal my rulers all the time. Well, I'm the department head, so I have to tolerate. There, I do have a little box of rulers. I encourage you to get your own ruler, but it's not a bit, because then you have a ruler at home. But if you ever need rulers, they're there on the sideboards. Does anyone need a ruler today? They're Egyptian. They're Egyptian rulers. Rulers of Egypt? Well, it's hilarious if you think it over. You can always borrow those when we're graphing lines. I'll just throw some around there, and then you guys can borrow them and return them at the end of class. Don't snap my rulers, okay, please? All the time I look at my box and there's snapped rulers in there. I'm like, what is wrong with people? I don't need a ruler because I've got my fancy active board. Help me draw the line. Draw the line. And little arrows at the end to say, the only reason I stopped drawing this line is because I ran out of graph paper. The line actually goes forever. Does that procedure ring a bell for most of you? If not, I've put the fancy steps here so you can look. State the slope and y-intercept. I did that. I pointed at them. From the y-intercept, I did that. Rise and run according to the slope. Join the points, and then label the line. Ooh, label the line. Last year, your grade 9 teacher was supposed to sort of let you away with it if you didn't label the line. I'm going to give away something. Next chapter, we're going to graph 2 lines and see where they meet. Doesn't sound that hard, does it? If you can graph 1 line, we're going to graph 2 lines, see where they meet. Then it's going to become important to label the lines because there's going to be 2 different lines going on. So let's start getting in the habit of labeling lines on the page so we know which one's which when we start doing 2. In fact, if you can graph this, one of the lessons in chapter 1, you're already like, I can do that. You mean graph 2 of them and just look and see where they meet? That's all we're going to do on one of the days in chapter 2. Chapter 1. Okay, you have the questions? What questions do you have about that? Mr. Talent, I'm only sort of good at this. I sort of remember it. It's okay. We're working on it because I'm going to do a whole lesson on it later, you know? So you survive on the quiz and we carry on. Okay? Method 2. Okay, now let's be clear about the situation here. If the equation's given in y equals mx plus b form, this is the way to go. If the equation's not given in y equals mx plus b form, like this one, you have 2 choices. You could rearrange and get it like this one. That's one good choice. Another good choice is to use what's called the x and y intercept method. And before you give up on this method, watch how smooth this is. It might be better if you really give it a chance than doing y equals mx plus b. I'm going to do 2 things. I'm going to find what the x-intercept of this is. By setting the y to 0. If that seems like a magical choice, wait till you see me graph it and you'll see why I did it. Okay? So I'll circle back to that in a second. Now, the easiest number to sub into any equation is 0. That's always easy to sub in because watch what happens to this equation when I sub in 0. Most people who have experience at this don't even write that line that I just did. They jump to that second line because like, I'm subbing in 0. I don't need to write the term with the 0 in it. It's going to be 0. And then I only have one more step. Divide it by 2. And I have my x-intercept. I've already got one of the 2 points I need to draw my line. Very quickly. If you didn't think that was very quickly, when I do this on the other side of the line, I'll do it the quick way. So you can see how quick this can go. Now, circle back. Do you see why I had to set the y equal to 0? An x-intercept, to be on the x-axis, you have to have y value 0. That's why I subbed in y equals 0, because that would find the x-intercept. Now I want to find the y-intercept. I'm going to do this one faster on purpose, not to confuse you, but to inspire you that this can go really quick. For y-intercept, I'm going to skip a line, which I'll fill back in a second if you want it. For y-intercept, set x equal to 0. And if I'm setting x equal to 0, that means that x term becomes 0. I don't need to write it out. You can, but I don't need to write it out. That's going to become 0. And so then I only have one more step to go. 8 divided by negative 4, and the y-intercept is negative 2. Here's that extra step, which I'll change colors, because I really do think it's an optional step. Subbing in 0 is a seriously powerful move. Well, that's enough. I know on the previous one I said get more than 2 points, but I only said that to make your ruler life easy. You don't need more than 2 points. 2 points is more than, it's not more than enough, is just enough for what we're trying to do. Help me draw the line. Oops, that didn't go well. My new board is a little more difficult to get right on the points. And then I'll label that line. Now, sometimes people don't remember that procedure quite as well. How many remember doing that, doing x and y intercepts? So some of you do, okay. It's okay if you don't, but it's worth trying because it's pretty straightforward. It's nice. You sub in 0 for x, see what you get. You sub in 0 for y, see what you get, and you draw the line. To me, there's less to remember than y equals mx plus b. I'm not putting down y equals mx plus b, but this is a neat procedure. Okay? Do you need a ruler? Do you want a ruler? Oh, she's got one. All right. But I paused for questions. And again, I talk to anyone out there who this feels very rushed. If you're like, holy crap, I can't remember all this stuff this fast. Maybe I shouldn't be an AP. No, Mrs. Todd, my wife, is teaching the regular academic class. She's teaching the exact same lessons. She's at the exact same spot I am. She might be answering more questions, I guess, maybe. But it's okay if you're like, I don't remember every single step of all this. That's okay. We got time. We're going to wander our way through this. This is just me going and saying, here's some things you saw in grade 9. You know, at the start of an episode, sometimes they say, the little recap. Last time on, I don't want to say a show that I know about because that'll be too old. What's a current popular show? They used to do this on Game of Thrones all the time, right? Last time on Game of Thrones. And they go through a whole bunch of stuff and go, I don't know. It might help you to know this stuff. That's sort of what this is. It might help you to see this stuff again before I start the episode. Freak out? No, it's okay if little details are not quite there yet. That's what the practice questions are for. Okay, special lines. Oh, we did talk about special lines a little bit. Here's the review of special lines. Horizontal lines have slope 0. The equation of a horizontal line is, actually, I want to explain this. Somebody might go, isn't the equation of a line y equals mx plus b? And I say, yeah. Equations of lines are y equals mx plus b. But in this case, the slope is 0. So really, the equation of this line is y equals 0x plus b. And if I wrote this on a test and said, what's the equation of a horizontal line look like? And you wrote y equals 0x plus b, I'd mark it right. I wouldn't be sad. I wouldn't do my unhappy dance. I'd be like, yeah, that's right. But you could just write y equals b. 0 times x is always 0. And so the equation will simplify down to y equals b. That is, y equals whatever the y-intercept is. And I'll do an example in a second. I'll graph that. Now, vertical lines have a slope of, again, imagine skiing. You're like, la, 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 la. Oh. Yeah? That's my best example I can give to try and help you picture why vertical lines have undefined slope. There's no really good way to talk about the slope.
Hello, Mr. Todd.
Howdy.
Is Alina Hassan in class?
Yes?
Could she come to student services, please?
Certainly.
Thank you.
Mr. Todd, you just gave us a formula for finding slope. I'm going to go home tonight and I'm going to find the slope of a vertical line. I'm like, oh yeah? Do it. Watch this. I'm going to make a vertical line. It has points there and there. Vertical line. You're going to be the one that figures it out. Look at this. Aren't you excited? Slope of a vertical line. Here's the 2 points you're going to use. 4, 7, and 4, 2. Yeah? And you get your slope formula out, and you go, okay, y2 minus y1 over x2 minus x1. Slope is 5 divided by 0. Dividing by 0 is out. We made a mistake in teaching you, friends. Did you ever do like Mad Minute or multiplication competitions in your class where you had to do the flashcards? Whoever the best person in the class was had a weakness, a vulnerability. 0. Right? You put those flashcards up. 6 times 8, 48. 7 times 9, 63. They'd kill everybody because they were good at it. 8 times 4, 32. So you get up against them and maybe you weren't quite as fast as them and you're like, come on, 0. Come on, 0. Come on, 0. 0 times 8, 0. And they're like, because 0 is easy, isn't it? 0 is unbelievably, impossibly hard. But if you're just multiplying it by something, 0 doesn't seem like a big deal. Dividing by 0 is out. You cannot divide by 0. There's no such thing as dividing by 0. It's not like, oh, I'll show you in later grades. It's not like, oh, we need a new Einstein for the new generation to figure out how to divide by 0. Here, I'll very simply show you why you can't divide by 0. Let's say I had $20 and I want to divide it into piles of 5. How many piles of 5 would I get if I divided up $20? 4. That's what division's for. That's what division does. It divides things into piles. Okay? Let's say I had $20 and I wanted to divide it into piles of 2. How many piles of 2 would I get if I'm dividing up $20? 10. You're right with me. Everything's good. 1's an interesting number because watch what happens with 1. Let's say I wanted to divide 20 into piles of 1, into loonies. How many loonies are in 20? 20. Okay, so that's pretty nice. Here's an interesting one that will help you with maybe your fraction understanding. What if I wanted to divide $20 into piles of quarters? That's really small, into piles of quarters. How many quarters are there in $20? 80. You didn't do divide there, did you? You did multiply by 4. There's something about division and multiplication and flipping things around going on there. And we'll talk about that when we deal with fractions more. Get ready for this one. And watch the expression on my face. Sorry, video people. You don't get to see the expression on my face. I'm going to take $20 and divide it into piles of 0. Huh? What do I? That's not how you divide things. You don't divide them into piles of 0. How am I going to start peeling off zeros here? Or if you're really out there, if your brain's like way out there like Pluto, how many piles of 0 am I going to do? An infinite number. I'll never get done. I'll always have $20. Dividing by 0 is out. I'll check my calculator, Mr. Todd. I'll show you. Oh yeah? Try it out. Someone punch in 20 divided by 0 and watch what your calculator does. Math error. It goes, nope, sorry, can't be done. It's actually not can't be done. For those of you who are like, maybe I can do it. It's more like shouldn't be done. A really good calculator would have a battery hooked up to the equal sign. If you typed in 20 divided by 0, you get a little shock. Yeah? 20 divided by 0. Ooh, ooh, ooh. 20 divided by 0. Somebody says, I'll do it. I'm really good at equation solving. I'll find out what it is. Here we go. X equals 20 divided by 0. I'll solve this equation. What's the opposite of dividing by 0? Multiplying by 0. 0 times x equals 20. So all I got to do is find out something that when you multiply it by 0, you get 20. What number can you multiply by 0 and get 20? There's no number that multiplies by 0 to get 20. If you want 0x equals 20 and I get 0 equals 20 and math breaks down, and that's literally what happens when you try to divide by 0. Math breaks down. Okay? Oh, we slipped off the edge of the world there, didn't we? All that to reiterate. No dividing by 0. Not allowed. So we call it undefined. Vertical lines have undefined slope. We don't have to get that crazy about it. We just have to go, oh, oh, oh. Can't talk about the slope. I can graph them. But the equation will look like this. X equals A. Don't let that freak you out. I mean, X equals something. Let's graph the line. Let's do these ones first. This is the first one I'm going to do. Yeah, it's something. A is going to be something. And I'll show you what I mean in a second. I'm going to graph the line y equals 2. Not using anything I've done before, actually. I'm going to graph it a different way so you can really see what's happening. The equation says y equals 2. So I say, well, what if x equals 1? What will y be? 2. What if x equals 2? What will y be? 2. The equation says y equals 2. No matter what you do, y equals 2. You say, okay, well, what if x equals 3? The equation looks at you like, I'm not doing this all day with you. Y equals 2. I'm like, oh, okay, so when it's 3, y equals 2? Yep. You go, well, what about when x equals 4? The equation's like, I am Groot. Yes? 2. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Y equals 2. You're like, oh, y equals 2. Equation's like, yeah, y equals 2. Now, I know that means if we built the equation of the line, that this would be y equals 0x plus 2. Slope 0, y-intercept 2. I know that, but that's not the point. Y equals 2, always. Using that, can someone describe to me what the line y equals -3 will look like? Where will it be? What do you mean? What do you mean -3? The y-intercept's -3, and it just keeps going across at -3 the whole time. Now forget undefined slope, forget dividing by 0, forget all of that stuff. That's all true. But if that is the line y equals 0, and that is the line y equals -3, what's the line x equals 4 look like? X equals 4. All the time. All the way through this line, x equals 4. Watch. X equals 4. X equals 4. X equals 4. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. And all those dots are actually what's happening. That's not me being silly. That's what the line's all about. It's a whole bunch of points, all the points, where the x value happens to be 4. So you don't have to fall down the rabbit hole of undefined slopes and dividing by 0 and all that stuff to be able to go, oh, a line that says x equals 4 is all the points where x equals 4. And over here is x equals -1. And somebody asked, what does x equals a mean? And I'm like, nothing. It doesn't mean anything. It just means the equation of the line is going to look like x equals something, some number. You're going to get some number there. So when you see this a, it's just whatever number's in the question. Does that help you with special lines a little bit? And make them a little less special? It's a little less special now. They're actually the easiest lines to do as long as you know what's going on. Any questions about special lines? Oh, and just a couple word problems to end up the day, but they're a little bit, this is the hard part. And okay, let's just fast forward ahead about 6 or 7 days. It's going to be 2 days in a row where we just try and build these equations. So this is just me going up to the lake of word problems and dipping my toe in a little bit and going, let's just check the water here on word problems because some of these are quite difficult. Quite difficult. Some aren't. With 2 or more equations are used to model a situation, it's called a system of equations. If they're all linear, it's called a linear system, and I'm just going to label this and call this is what we're going to do in Chapter 1. Coming up. Coming soon to a math class near you. 2 lines at once. That's all. Find suitable variables for each situation, then write an equation. Okay, Sam needs to rent a car for the day. Rent a Heap charges $50 per day plus 12 cents a kilometer. They want me to make an equation. What's supposed to happen here is your brain's supposed to go y equals mx plus b. You're like, the only equations we really know at this point are linear equations. So I'm going to use y equals mx plus b. I could use other variables, but y equals mx plus b. Okay, so what's the y-intercept for this situation? What does this start at? 50. So I think when you're building equations for y equals mx plus b, you actually start over here with the y-intercept and go, hold on, where's this thing starting at? And this one's starting at $50. When you go to rent a car, they're like, it's $50 to rent the car. Then it depends on how much you drive it. That's the rate of the situation. So the slope here is the rate. How much is this thing going up by? So that's what goes here. I'm not going to talk a whole lot more about word problems than that right now, just to go, oh. Those of you who are doing y equals mx plus b and were thinking, when am I ever going to use this? Or had an uncle looking over your shoulder at your homework going, oh, you never use that stuff. Like, right here, this is how we're going to use this stuff. By taking the two numbers in the linear situation and putting it into our formula. See, now, if I wanted to know how much it costs if I drive 1,000 kilometers, I can just plug it in and get the answer, okay? You're like, I can do that without your equation. I know. Tougher equations coming, yes? But do you have any questions about that? A piggy bank contains $5.25 in nickels and dimes. This doesn't look the same at all. This is still a linear situation, but it looks really different. You going to take a shot at it? Oh, 5.25. 5.25 is definitely involved in this situation. One of the most powerful things I'm going to show you all year is going to happen right now. Let's say you're confused by this, like, well, how am I supposed to do this? I'm going to show you a method you think is not very mathy. It's extremely mathy. This is like I say, one of the best things I'm going to show you. Over here, I'm just going to call this my math playground. We're over here, I'm just going to think a little bit about this situation. And I'm going to do a guess. And I'm hoping to guess wrong here. Somebody use small enough numbers that it's not going to come out to $5.25. Can someone guess how many nickels and how many dimes are in the piggy bank? Just a complete guess, but for the sake of my example, keep your numbers so unbelievably small that it's not correct. It's not going to be $5.25. How many nickels, how many dimes? One nickel, one dime. Yeah? Clearly, that's not going to work. But this helps. This is giant algebraic help. Those of you who have trouble coming up with word problem equations, this is what you do. You go, well, what would I do? How much money is in this particular piggy bank? Nickels. 5 cents for each one. So 5 cents times 1. And then 10 cents times 1. Is that going to add up to $5.25? Clearly not, but that's how you calculate the number of nickels and dimes. I'll do the next one. Maybe it's 7 nickels and 13 dimes. That's not correct. That's not enough money. But if I was going to use that and find out how much money, then I'd go 0.05 times 7 nickels, then 0.10 times 13 dimes. That's how I'd figure it out. It's not going to be right. I've got to get the right numbers here to get $5.25. So I need 0.05 times nickels. What letter would you like to use for nickels? N? What the heck is going on here? There. plus 0.10, oops, I said 0 and wrote 1, times dimes. That's how we find out how much money I have. What's that got to come out to be for this to work? $5.25. Please don't underestimate what I just showed you over here in the math playground. That's how we come up with algebra situations. We just go, well, what would I do with the numbers? And maybe some of you are good enough conceptually that you don't need too much of the math playground, but that's all that's going on here. 0.05 times the number of nickels plus 0.10 times the number of dimes has to come out to $5.25. Little intro to chapter 1 though. There's lots of different combinations of nickels and dimes that might be the answer here. We need more information to actually get the number of nickels and dimes. You could find many answers to this question. If that gave you a headache, good. We're on the right path. Yeah? What I mean by that is, if I was your personal trainer and you came to the gym, after an hour, hopefully you'd be like a little sore. You'd be like, that was, geez, that hurt a little bit. Really good math lessons will hurt a little bit up here in your brain. You're like, I don't know if I got it or not. Yeah. Is it one more example? My brain tells me it's one more example, even though my page numbers are telling me it's two more. Sarah has a day job and an evening job. She works 45 hours in total. Let's try the math playground method again. Over here in the math playground, which I will call MP, math playground, it's just me thinking this out. I'm going to play around and try and figure out what the equation would be. Having said that, who conceptually can already jump ahead and grab an equation for this situation? He's got a day job and an evening job, and those, Destiny's hand wants to answer. I don't know if she wants to. She can't tell. 45 equals, say it again? Day plus evening. Yeah, so D plus E, whatever the day hours are plus evening hours, have to add up to 45. So it is possible in some situations that you don't need the playground. Yeah? But here's my guess over here on the math playground. I go, well, what if her day hours, she did 5 day hours, and her evening hours were 7. Would that work? 5 plus 7, does that come out to 45? No, it doesn't. Well, maybe the answer 10 and 3. And incidentally, people, I'm not actually trying to find the answer. I'm just trying to go, how do I find the answer? And this is 10 plus 3, day plus evening. So day plus evening, we want to come out to 45. And she put the 45 on the left. Yeah, it's no problem. 45 can go on the left. Now this is hard. Just put this in there to just poke you in the eye and go, what do you know? Justin deposits money into an account that earns 4% interest and someone into an account that earns 6% interest. Yee. Account 1. Account 2. Oh, this is hard. And if your brain has just had too much, that's okay. We don't really need this for a couple weeks yet, but what's my guess? He earns $155 in interest altogether. Maybe he's got $10 in account 1, and he's got $5 in account 2. How would you calculate his interest? Well, you'd go 4% of the first account, and you'd add that to 6% of the second account. And I want to tell you, friends, that this math playground method, lots of times you only got to do one. You just got to once go, what would I do with 2 numbers? You don't need a couple of examples, because that's enough to go, we need 0.04 times the first account plus 0.06 times the second account. We need that to add up to $155. Okay? That one especially is meant for me. That's me grabbing each side of your brain like this and going, hey, just for some fun, let's go, and see if your brain goes, and see what happens. More of that coming in chat. Let's not get derailed by that. Promise me you don't get derailed by that. Promise me you don't go home tonight and stare at that thing and go, maybe I shouldn't even be in academic math. I don't get it. Stop it. Settle down. You're in the right place. That doesn't mean it's not going to hurt a little bit along the way. Yeah? Is that the end of finally day 2?